Because we didn't finish section 3.4, let's take a minute and review what we already know. So far in 3.4, we've discovered what a vertical translation is and what a horizontal translation is. So if I take a function and I add a constant to the end, what does that move it? Up or down? It moves it up k units. If I take the same function and I subtract k from the end, it moves it down k units. If I take a function and instead of adding or subtracting to the end, I add or subtract to the inside of the grouping symbol or the parenthesis, say I add k in there, which way does it move it? Be very careful.
Left.
That moves it left. This one is the opposite of what you think. And if I want to move something to the right, I subtract that number on the inside of the grouping symbol. So you have to be really, really careful with the horizontal translations. And that's all we've kind of covered so far. I also wanted to go back real quick and just sort of talk over the parent graphs. There are 5 of them that I want you to be very, very familiar with. So I'm going to kind of flip over here, and we're going to just kind of graph the basic parent graphs. These are the families of functions you need to be really familiar with. Parent functions or parent graphs. The first one is absolute value. So this is the parent of the absolute value graph. That's sort of the most basic one you can get. And we know that he looks like this. What's this point right here? Name it. That's the vertex. And for the parent function, it occurs at 0, 0. Okay? Then there's a point at 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. That's the parent of all absolute value. Then we can start shifting them up, down, left, right, and all kinds of good stuff. Let's also talk a little about the basic quadratics. The basic quadratic is y equals x squared. That graph will look like this, an upward parabola with a vertex where? 0, 0 at the origin. In fact, you guys, all 5 of the parent graphs go through the origin. They have the point 0, 0 and the point 1, 1. Those 2 points are common to all 5 of the parent graphs that we're going to study. Then we'll talk about cubics. X to the third. X to the third goes through 0, 0. It has this little curvy look to it. So it's a little harder for some people. So that's what the basic x cubed looks like. This is 0, 0, 1, 1, 2, 8, 3, 27, negative 1, negative 1, negative 2, negative 8, negative 3, negative 27. So I just kind of wanted to review that. If we need it, we can talk about it a little more. Then that brings us to the square root functions. Square root function is square root of x. That's your most basic that hasn't been shifted or stretched or reflected or anything weird. Just y equals the square root of x. It looks like half of a sideways parabola. It starts at 0, 0, 1, 1, but it doesn't hit another integer until you get to x equals 4. That would be 4, 2 if I put x in there. So it's harder to find integers on it. And then finally, we'll talk about the cube root. The cube root, y equals the cube root of x, looks a lot like the cubic. But he comes through this way. So also goes through 0, 0, 1, 1, negative 1, negative 1. But he goes out here. There's a point at 8, 2 instead of 2, 8. If you think about it, if you put 8 in here, the cube root of 8 is 2. Those are the 5 parent graphs you kind of need to be familiar enough with that you could graph them or sketch them very, very quickly. When I say cubic, this right here should pop into your head. When I say quadratic, this should pop into your head. And same thing for the others. They just need it very quickly. You should know what they are. That's just a quick review before we get to reflections. Anybody have questions up to now?
So it's always going to have 8 too on a cubic.
8 on a cube root?
Yeah.
Yeah, cube root would have 8 too. This one would have the point 2, 8 if you think about it. Because if I put 2 in for x, I would get 8. So it actually kind of reverses the points, which is kind of interesting. Okay, so let's pause for a second and then take some notes on reflections. So reflections. A reflection is where a graph is completely flipped, is what I call them. To me, reflections are flips, and the graph gets flipped about a set line. And x-axis reflection, as you can see from this upper photo right here, takes the graph and flips it from above the axis to below. And if there's anything below the axis, what do you think it would do to it? It would flip it up. Yeah, it just takes it and puts it on the opposite side of the x-axis. A y-axis reflection flips it around the y-axis. So if I have this right here to start with, if I flip it, it will go over to the other side. Okay? The way you can tell is if there's a negative in front of the parent function, that goes about the x-axis. But if there's a negative inside the parenthesis or inside the square root or inside the absolute value, then it will go around the y-axis. So let's go add that over here to our list of things. So we have our horizontal and vertical translations already listed up there. Now let's add our reflections. If I put a negative in front, we said that is called an x-axis reflection. And a reflection is sort of like a flip. So it flips it about the x-axis. I call it an up-down flip. Flips it from up to down or down to up. If the negative is inside the parenthesis or the grouping symbol, it will flip it around the y-axis. So let's just look at a couple of examples of those.
Why did it say on the slide that it's like the same as f of x? Did you see that? Like,
Why did it say? It says it's identical except that it has been flipped around the y-axis. That's true for everything. All of these are the same as their parent function, except it has been either moved up, down, left, right, or flipped. That's what they're just trying to say, that it'll look just like the parent function, except it will have been flipped. Okay, so let's look at a couple. Here I want to first look at g of x equals negative absolute value of x plus 1. G of x equals negative absolute value of x plus 1. Let's talk about part A first and ignore part B for now. Tell me what the parent graph for part A is.
x plus
Y equals
absolute value.
absolute value of x. Right? Okay. Tell me what's been done to it. It has a negative in front and it has a plus 1 on the inside. So talk to me first about the plus 1. The plus 1 on the inside, how does it move it?
Left.
That's a horizontal shift. So it's going to go left 1 unit, and it's going to be reflected about what axis? The x or the y? The x. It's going to be an up-down flip because the negative is outside. So it's going to be an x-axis reflection. Those are the two things we need to do to that parent function to translate it from the plane graph into the graph of y equals negative absolute value of x plus 1. So let's go graph the parent real quick. Parent is 0, 0, 1, 1, 2, 2, negative 1, 1, and negative 2, 2. So we'll just graph the parent there with a dotted line. Then I'll give you a second. I want you to look and see if you can figure out how to move it and flip it. So let's take each one of those points and move them left 1 and then flip it below the x-axis, because right now they're all above. So let's start with this point. Left 1, and then, see, that would be right here. If I flip it, do you understand that it will land here? Left 1 puts me here. Right now it's 2 above the x-axis. Flipping it will bring it 2 below. So left 1 and flip. Left 1, flip. Left 1, flip. How do I flip that? If it's already on the axis, does it move? No. If it's already on the axis, it stays there. This one, left 1 and flip. left 1 and flips. So it flips from up 2 to down 2. So you have to be really careful with those. And then, of course, most of you have graphing calculators, so you could go and check and make sure you got it correct, right? So you should be able to check, and you can even look at your table and make sure you got those points correct. So there's part A. Let's erase all of this and look at part B. Okay, let's look at part B. Part B is a little easier because it doesn't have any shifting. It only has a reflection. So we look at part B. What's the parent of B? Y equals square root of x. And the only thing that's different is there's a negative on the inside, which means it's been reflected about the, there's a y-axis reflection. That's the only thing. There is a y-axis reflection. So we're going to go graph y equals the square root of x. That graph's at 0, 0, 1, 1, and 4, 2, correct? Is that okay, guys? Okay, then I need to take that graph and I need to flip it around the y-axis. So this point will stay, but this point will hop over here, and this point will hop from here over to this way. So it has to stay 4 units away. 1, 2, 3, 4. So when it flips and comes around, it'll be 1, 2, 3, 4 that way. And there's the graph of y equals the square root of negative x. Make sure you kind of check into that.
You said it's 1, 1, and 4, 2, 4, 2.
Yeah, 1, 1, 4, 2. So now it's negative 1, 1, and negative 4, 2 when you move those points over.